Good evening, everyone. My name's Harvey from the National Self Build and Renovation Centre. I thought I'd just come on a minute early because I can see in the chat a couple of people just wanted to test the sound. So Nina, I'm hoping that I'm coming through loud and clear for you all. Perhaps if you could, if someone could just be kind enough to put that in the chat, whether you can see and hear me okay, that'd be great. So my name is Harvey. I am the Managing Director and Employee Owner at the National Self Build and Renovation Centre. I'm currently broadcasting to you live from my kitchen, as I have done from most of these online sessions that we've run this year. Thanks, everyone. Brilliant. Looks like the sound's coming through great. So it's 7 o'clock, so we will get started. Thank you so much for joining us for what is our 10th online surgery. So the NSBRC, we're celebrating 15 years of the centre this year. And one of the promises that we made was that we were going to produce an online surgery once a month with a different topic and theme. Back in August, we ran a session on heat and energy, and it will probably come as no surprise that it was one of the busiest online sessions that we've ever produced. We had 444 people online, and that was following a very busy eco workshop that we'd run at the centre a few weeks earlier. And from that session on heat and energy, one of the big bits of feedback that we got from attendees and visitors to the centre was, can we have a session on insulation? So here it is. So the next 2 hours, we are going to be focused purely on insulation. Now, just to run through the agenda, once I've finished my introductions, I'm going to hand you over to Rob Bone from CLPM. Rob is a project manager, heating specialist, and also presents several of the courses at the NSBRC. And he's going to give us a broad overview of all things insulation and the types of things we should be thinking about and the questions that you should be asking. And then we're going to hear from a number of specialists. So Martin Randall from Extratherm Insulation, Jonathan Parsons from Marmox UK, and Jasper Mead from PYC Warm Cell Insulation. And then we're going to wrap up the session with a Q&A. And we've allocated at least half an hour for that Q&A. Now, I am going to manage expectations for everyone and have a bit of a request. So at the moment, I can see we have 324 people logged on already, and I'm expecting probably 400 or 500 people to join us this evening, which is fantastic. So thank you one and all for joining us. Now, pure maths tells me that we won't be able to get through all of your questions. So I'm hoping that the presentations that we're going to have over the next hour and a half, so the first 4 presentations, will broadly answer a lot of your questions on insulation. But if you do have questions, please use the Q&A function. I can see a question's just popped up in there, which is great. So I won't be able to monitor the chat as I'm hosting the session this evening, but I will be able to monitor the Q&A. And the second reason why it's important to use the Q&A button is if we're not able to get to your question this evening, and being honest, looking at the numbers, we won't be able to get to all the questions this evening specifically. If you use the Q&A button, the questions will be captured as a text file, and I will then be able to send those questions to our 4 panelists this evening, who will be able to look at those questions separately and then provide some responses. Now, this session is also, as with all of our online surgeries, being recorded. So we will send you out a copy of this session so you can watch it back in your own time. So hopefully you can catch up with all the information that's going to be divulged over the next couple of hours. And when we send that copy of the recording out, which normally is in a couple of days after this evening, so hopefully by the end of this week, we will, if there are some key questions that keep coming up, we will look to address those, and I will send those responses out with the recording. So I'd encourage you to use the Q&A button for your questions, but please be a bit patient with me and the guys if we don't get to your question this evening, just as purely a matter of time. So let's get straight into it. So I put a poll up on the screen, which I can see a number of you have responded to. So I'm just going to share the results just so that you at home and the panelists can see who's joining us this evening. So we have 25% of you doing a new build, 68% looking at existing properties, and 7% undecided. So I read a really fascinating fact this week actually on existing properties. So there are 29.3 million homes in the UK, and 36% of those were built before the Second World War, which I was absolutely staggered at. So we have a very old housing stock in the UK, which presents its own problems, and as I'm sure that many of you will appreciate, in terms of how do we improve the efficiency of those homes. So that's interesting. We've got a real mix, a quarter new build and a good 2/3 doing existing properties. I'm going to stop sharing that now. If that's still on your screen, just click on the little cross in the top right hand corner of that box and that will disappear. And I'm going to ask the first presenter, who is Rob from CLPM, to say hello. So Rob, if you're able to turn your camera on, please.
Good evening. Thank you, Harvey, and good evening all online. So my name is Rob Bohm. I work for a construction consultancy business called CLPM Limited. We help people like yourselves, either with new builds, renovations, extensions, to look at ways of making your home better. We have a quantity surveyors and project management team, as well as myself, who heads up our energy and sustainability team.
Brilliant. So whereabouts are you joining us from, Rob?
So I'm joining you from my little office in deep and darkest Cotswolds. The business is based nearer London, but I do travel all over the country, and I was down in Devon today for my sins. So that was very nice, sunshine little trip down to Devon today to look at someone's beautiful house who needs a lot of help to try and make it better. So yeah, that's generally what I do.
And I will say, Rob, your name is coming up with 2 B's, but that is my mistake. It is Rob with 1 B. So apologies, Rob, that you've come up as Rob with 2 B's. But Rob was talking to me on the phone earlier, and it is Rob with 1 B. But Rob, apologies for that. So we will, yeah, brilliant, Rob. If you could share your presentation. So it is just gone 7:05. And
is it sharing? It should do.
Yeah, I can see it. If you just want to put it into presentation mode now.
Absolutely, I will.
Yeah, we are just Rob, just so you know, on that version we can see your next slide and notes. I don't know if you want to put it into slideshow mode instead.
I did, but it's just come up with the other one for some strange reason. Bear with me a second.
Okay, that's the joys of these live sessions.
So if I close it again. From the beginning. Is that sharing now?
Yeah, we can still see your next slide, but I don't think it's going to impact the presentation too much. So I think that's fine, Rob. So I'm going to disappear, and you've got about 20 minutes.
Oh, sure. So as I said before, my name is Rob Bohm, and we do help people with insulation. So the first thing to think about is why do we insulate? It's very simple. In excess of 60% of our energy use is generally down to heating, and obviously that will fluctuate depending on how good a performance house you have. So the first thing to really think about is your building fabric. That's a really, really important thing to do with all houses. So the fabric we class as effectively walls, floor, roof, windows, doors, you know, any part of the structure of the building. And we had to find ways of improving that fabric in general terms. So the insulation is the key point in terms of trying to build up the thermal performance of the walls, but also the air tightness is really, really important as well. So you could have the best insulated house in the world, but if you have a drafty house, you might as well leave the doors and windows open and you negate all the improvements of the insulation. Now, people always talk to me about, oh, I'm looking to do some heating improvements, or maybe going to change my boiler, or maybe think about doing a heat pump. That's all good, but you must consider the thermal improvements of your building to start with, because it will affect the type of heating system that you are able to have. The simple question is, you know, people always say, can I fit a heat pump? And I say, potentially, but it depends on how well your building performs in terms of that situation. So it's absolutely vital to make sure that your house is good. So when we look at our houses, we have to think about all the different areas, as I said before, where we may be losing airflow through, but we also need to think about ventilation. The ventilation is still very important. We need to breathe, our houses need to breathe, and every time you sort of open your washing machine, your dishwasher, so on and so forth, moisture comes into the house. So ventilation is still important, but what we want is controlled ventilation rather than just drafts, as far as that's concerned. Now, drafts can pass through windows and doors, but also into basements if you have a suspended floor, and obviously through the walls and through the roof. So that's things to think about. Now, we've all watched Grand Designs, and especially these people who are thinking about new builds, and see lovely, lovely lots of glass in the back of the house, which is beautiful. We all have lovely views and so on and so forth. but you must be aware that even the best glass available on the planet is way inferior to a good wall. So therefore, if you're putting lots of glass into your property, you may compromise how the building performs. Also, glass is a lot more expensive, and also you do have the risk of heating as well. Now, when you're looking at a new build, there's no secret to why passive houses tend to be cuboid, because that's generally the best shape for a house in terms of external area versus the internal area. So that's why we look at simple shapes for passive houses. If you start going for really complicated layouts, that unfortunately has an impact because you have a greater surface area in terms of the actual build. So when we talk about houses, we talk about U values in terms of insulation. So U value basically is the total insulation value for the wall plus whatever you have in it. So if you have a high U value, a high number, that means the building performs poorly. If you have a low value, then obviously that means it performs well. So the lower the U value, the better performing the house will be. Now, something you must think about is when you think about different types of insulation, you must compare like for like to make sure you are getting the same U value or better. And the same compares with glazing. So if you say, well, actually, I'm thinking go for double glazing or triple glazing, well, you must make sure that the performance is comparable, and like comparing similar glazing systems. And also, if you look at the U values for glazing, make sure you have a comparison for the frame as well as the glass, and not just the glass, because you may find there may be some discrepancies as far as that's concerned. Now, going back to our draft proofing, ventilation is important, but so is airtightness. So if you want to go for a super airtight house, then you have to think about how the building is going to be constructed and sealed up, no trickle vents, and then mechanical ventilation. But it can make a huge difference in the performance of your property in terms of how much energy you use, but also the comfort levels. Having a very well ventilated house is very, very nice. And the MVHR systems, mechanical ventilation with heat recovery, they're very efficient because they pre-warm the air coming in. So these things are important things to be thinking about if you're designing new. You can think about this if you're doing a deep retrofit, and if you're actually improving your house substantially from a bare strip down. But if you just have an existing house you wish just to improve slightly, improving the air tightness massively is quite difficult and quite complex. So insulation options. If you look on the market, there are very many different types, and we use multiple ones in a single house because they all have their place. So if we go for our sort of standard off-the-shelf insulations, the fallback PIR, as we call it, insulation, Celotex, Kingspan, etc. Rigid board material, we use that primarily in areas where we need a very high U value, so very low value, high performance on the walls, but also in areas like stud walls, areas where we don't have much thickness. Mineral wool, rock wool, etc. is quite often, as you see, we roll that out in loft spaces or areas where we don't need such a good U value, or we have plenty of space to be able to double or triple it up. Because mineral wool, such as rock wool, etc., has a poor performance than Celotex and Kingspan. Fiberglass wool, it's the old insulation material we find in everybody's lofts. Generally speaking, we kind of leave it in place when we, ask people to re-insulate their lofts, because taking it out is a bit of a mess, and it just does compact where mineral wool doesn't. Expanded polystyrene, again, that's something which you'd find in older houses, which now we fit Celotex instead. It has a reasonable performance, and the denser material is quite good, but generally speaking, it's still not as good as Celotex. Then we have multi-layer foil, which can be used in some areas where there's really is tight on space, and it's very difficult to put anything else in. Then we can talk about the eco options, which I get asked about many times, because people thinking about sort of lowering their carbon element, because unfortunately all of the really high performance materials such as Celotex obviously aren't particularly nice chemicals, and have a high carbon content. Where if we start looking at things like wood fiber, which basically can be compressed into sort of quite dense boards, so effectively replicating Celotex and Kingspan. Then we have sheep's wool, which again can be sort of replicating the mineral wool. And then we have hemp, which can be then used again similar as a mineral wool type. We have cork, which can be used into boards. But unfortunately, all these materials are very nice, but they tend to be quite expensive, and there are other issues regarding them as well. So when we look at your different types of insulation, you must be aware that different thicknesses are required to achieve the differing U values. And unfortunately, the more greener option means you, generally speaking, have a poor U value, which means you need more of it. Now, if you have lots of space, that's not an issue. And if you're building a new build house and you wish to use the eco option, then you must actually think about that at design stage, because effectively you may have to make thicker walls to allow that to actually work in that situation. Where if you want to use sort of the unpleasant materials, generally speaking, you can get away with it. There are exceptions to the rule. We have a material called aerogel, which is a silica board. And this is a breathable material, which is very, very good. Comes in a very thin board material, but unfortunately is quite expensive. And that's part of the problem, is the natural materials tend to be quite a lot more expensive. Now, for those who have existing properties, when you're thinking about insulating areas, you must leave some parts of the building to breathe. If you do not let the building area to breathe, if you have solid masonry walls, then eventually you can cause issues. So if you use like a PIR Celotex type board and stick it to the inside of your wall, and the wall is damp, moisture travels through it, that moisture will condensate and cause issues on that wall. You must therefore use a breathable board or a breathable material system to allow that moisture to evaporate into the room. But also you must think further down the line as well, in terms of lime plaster, breathable paints, and so on and so forth. It's no good sort of going down the route of a nice breathable insulation material and then finding that actually by putting vinyl matte emulsion on it, you've trapped the moisture in, and then all the paint then peels off. Now, when you think about the lovely sort of eco materials, you must also think about the cost of application. So, for example, you can get cork-based plasters, which you can put onto existing stone walls and the like, but it must be layered, and it does tend to be quite thick. So you have an extra sort of labor cost as far as that's concerned. It all takes much longer to fit. Something else to think about is that if these sort of eco materials are not actually applied sensibly and actually done with due care and attention, what can then cause issues is the actual material can actually decay. It can actually rot. And there are cases where this does actually happen. So the careful application is really, really important. And to make sure that people who are actually using materials do know what they're doing. So in terms of construction, if you are looking to use these kind of materials, you find that some of the suppliers actually will do courses for people to go on to understand the materials if they want to use them. But there are benefits. Some of these new materials are completely fireproof, which is quite surprising. Like warm cell insulation fiber, it's actually made on from waste paper, but it's mineralized and it does not burn. It is very, very good. Now, something also to think about is that potentially some of these natural products that our little furry friends might actually want to live in it as well, and that's something you must think about. So trying to keep vermin away from it is very important. But the beauty of it is because it's a natural product, you do not get off-gassing of horrible chemicals. And if you're building a new property, then there's going to be an awful lot of off-gassing as far as that's concerned. And even if lining existing properties, that does make quite a difference. So if the people are sort of looking to build new houses, well, you have got quite a lot of questions to ask your design team as far as that's concerned. So if you think about it, when you you design your house, you get your planning drawings, which are very pretty pictures, which tell you what the house looks like. It also tells you physically how big the house is going to be. Now, generally speaking, quite often some planning authorities say you must build out of the local vernacular, out of the local materials, which is absolutely fine. But what the planning drawings don't tell you is the internal size of the property and also what it's made from. So once you've got planning permission, you still have a choice of how you're going to build it. So traditionally, we've been going down a masonry route of maybe stone or brick or block on the outside, cavity with insulation in between, and then we go for a block material on the inside. Now, the brick and the block, the masonry and the stone offer little in terms of insulation, and it's a cavity with the insulation within the cavity which gives you the main thermal barrier. So generally speaking, unfortunately, bricks and blocks and stone are generally quite thick. They form the structural integrity of the building. So therefore, because they offer little in terms of insulation, then you need quite a wide cavity with insulation in it to actually keep you nice and warm, which means the walls can be quite thick. Now, thick walls means you have less interior space and actually potentially devalue your property. The thicker the walls, as the house is actually measured from the internal for valuation purposes. So that's something even to consider. So you can maybe go down, more modern types of building, timber frame, SIPs, which is structurally insulated panels, or ICF, insulated concrete formwork. We've all watched Grand Designs and seen some disasters, but also some absolute stars of builds as well. And generally speaking, the disasters normally happen due to sort of poor technique and application rather than the actual systems themselves failing. And the beauty of using these type of systems is that potentially some of them can have a very low carbon content in terms of timber frame builds, and they can have relatively thin walls. So for example, if you are having a external rendered finish to your property, then rather than rendering a concrete block, you could render the timber frame, which gives you quite a thin build-up, which then gives you a very high performance build for a thin wall, giving you more internal space. So these questions are things that you can start speaking to your architect about if you're involved in that scenario. But the same applies if you're building an extension or to a new build, if the same situation comes up. So these are questions which you can speak to your architects, and if they are unaware of it, then there are plenty of specialist companies who do this every day. So it's something really worth considering and looking how this can happen, because it can make a big difference. On a construction point of view, in terms of costs, generally you find that the sort of more modern types of building do tend to be a little bit more expensive in terms of square meterage, but what you do gain is a very high performance house and quite often a very quick build. So why is a quick build important? Well, if you're building new, you may have rental costs, you may have other professional fees, and generally speaking, as the building is being continued, you have insurance costs and you have various other costs associated generally with the build, whether it be scaffolding, hire of equipment, so on and so forth. So if you go a traditional masonry route, generally speaking, it's a very sort of simple scenario. Foundations go down, then the bricklayers come in, start building the walls, then carpenters come in and put the roof on, then the windows can go in potentially, and then men can start working inside the property. Now, if you go for these sort of higher speed builds, generally speaking, likewise with SIPs construction, there's a lot of off-site manufacture, and that's a real bonus, which means the building can go up really, really quickly, which means you can be what we class as in the dry very quickly indeed. For a sort of an average sort of house, you can quite easily be in that situation within about 2 weeks. Timber frame equally can be very quick, and ICF, depending on the systems you can also be relatively quick as well. So the advantage of going for the quick build is effectively means that once the building is watertight, you can have guys working inside doing plumbing, electrics, and so on and so forth, and the guys working outside covering the roof, doing external cladding, and so on and so forth. And that can reduce your build time substantially, which can make a difference on your general costs. So to recap, don't just sort of accept the first thing that comes along in terms of what you're going to build your house or extension out of. Do a bit of research, come along to various shows. I mean, for example, at the National Self-Build and Renovation Centre, they have various exhibitions, they have show weekends where they're sort of really sort of extolling all the virtues of all these different types of builds and people you can speak to, and you can see the products there. So it is certainly a very good thing to do. And if you are considering doing your own self-build, again, it's certainly worth looking and doing a course. I mean, that's even the case if you're doing a major renovation to an existing building. It's certainly very beneficial to actually understand what all the pitfalls are. Well, I certainly hope that was very useful for you, and I'll pass you back to Harvey.
Thank you, Rob. That's great. I'm just going to stop sharing. That's perfect. Great. So, Rob, thank you. Yeah, really good overview there. I'm going to stick to time, so that I'm going to introduce the next presenter in a moment. I am going to ask you just one question, Rob, that came through. So this is from Tony. Tony asked, do we want to improve energy efficiency or reduce energy use?
Well, that's two different things. So energy use basically is if you make a high performance building, you are going to basically use less heating energy. It's as simple as that. So that's that situation. Energy efficiency can be sometimes put down to how you control your heating in your house. So for example, if you've got a no thermostat or a very basic thermostat, then effectively potentially your house is being overheated in areas where you don't need it. So that's improving efficiency. But also, for example, you may have an old boiler, which is working at a low efficiency, and then by putting a new gas-fired condensing boiler, that's ways of doing that. In terms of other efficiencies, for example, if you go for a mechanical ventilation system, that has a huge improvement because effectively you're dropping the air tightness. So effectively it is a combination of the two, but effectively one is more to do the fabric of the building, so we're actually using less energy full stop, and then the efficiency of the things you're actually using in the property. Hope that answers your own question, Tony.
Thanks, Rob. Yeah, fabric first principles is something that we always talk about.
Absolutely. Yeah. Fabric first is our mantra. We've been banging our drum for quite a few years now, and it's more important these days than ever was.
No, absolutely. Rob, thank you so much for that overview. So we will
Pleasure.
see you again in about an hour's time for the Q&A. So if you don't mind hovering in the background, and we will catch up with you again shortly. Thanks, Rob.
Okay.
So now I'm going to introduce Martin Randall. So Martin is from Extratherm, so a specialist insulation manufacturer. So good evening, Martin. How are you?
Hi, Harvey. I'm fine. Thank you very much.
Great. And whereabouts are you joining us from in the country?
I happen to be in Devon, where Rob happened to visit earlier today. Obviously not visiting me. Otherwise, he might have referred to Extratherm and not Celotex and Kingspan. But there we go.
Martin, thank you for joining us this evening. So just, Martin, if I could ask you to share your screen, please, and bring up your presentation. Just whilst you're doing that, we now have 430 people online. So thank you all so much for joining us on this Tuesday evening. It just goes to show how topical this efficiency and insulation is. So thank you all. And just a quick reminder, if you missed it at the beginning, this session is being recorded. So we will send you a copy of this recording out in a few days' time once we've had a few little tweaks and edited it. So you will be you will have a lot of information over the next hour and a half. So don't worry too much, because you will get a recording and be able to revisit this in your own time. So Martin, that has come through great. So if you just would like to introduce yourself properly, and I'll be there in the background and see you in about 20 minutes.
Of course, yeah. So I'm Martin Randall. I'm one of the specification managers for Extratherm Insulation. I'm a chartered construction manager, energy assessor, and retrofit coordinator. So I'm going to discuss insulation from a regulation point of view. So I'm going to look at Part L Volume 1 in England. We'll look at the Future Home Standards quickly in 2025, go on to Wales, Part L as well. And then I want to touch on embodied carbon, because again, that's somewhere from a sustainability point of view that I think we should be looking at. So we're just going to go through a quick introduction to ourselves. Like I said, Part L 2021, 2025 Future Home Standards as proposed, the building regulations that come out in Wales in 2022. Then I'll go through some insulation specifications, introduce our new Eco 360 range, and then just quickly discuss the REBUILD Climate Challenge 2030. So Extratherm Insulation were founded in 1986. We've got now over 450 employees. We've got 4 production facilities, 2 in Ireland in Navan and Ballyconnell, and 2 in the UK in Chesterfield and Ross-on-Wye. We're part of a Unilin group of companies, and we have a vast range of thermal insulation materials for all sorts of specifications. We've got a full fill PIR, phenolic foam insulation, standard PIR insulation, an enhanced superior PIR. We do XPS, EPS, Stonewall, which is a non-combustible Euroclass A1 rain screen cladding insulation, and then we do a product called VIPS, which is a vacuum packed insulation panel. And we talked about performance products, and that performance has a conductivity of 0.007 compared to standard PIR at 0.002. So it's a significant improvement over that type of insulation. We suit applications like ground floors, external walls, roofs, soffits. They can be traditional masonry, timber frame, steel frame, concrete frame, and so on. Can also be an off-site construction, timber frame, and other sorts. So again, we have a lot of thermal solutions. So I'm just going to go quickly into Part L Volume 1. So this looks at the conservation of fuel and power. So I'll just quickly introduce you to that. So on the 15th of June of this year, it was implemented, so 2022, and it was a 31% improvement over the 2013 regulations. In 2013, we had two documents. We had Volume 1A and Volume 1B. Volume 1A was new build, Volume 1B was essentially extensions. We now have one volume, Volume 1. So there is a 1-year transitional period on that. So if you were lucky enough to pre-register, well, I'd say lucky enough, but National House Builders lucky enough to pre-register your build before June of the 15th, you have a year grace period. So if you make a start within that period, you would come under those regulations in 2013. If you don't, then you would come under the 2021 regulation. And I just mentioned this because it's more important for the National House Builders, not really from a self-build point of view, because you're keen to make your homes as energy efficient as you can. But from a National House Builder, they're keen to make as much money as they can, I think. So again, it's good from a new house point of view with people buying those homes. We then have performance metrics, so in something called SAP. So it's how we get compliance from a building regulation point of view for CO2, effectively. We have a primary energy target. So again, this typically looks at the energy in kilowatt hours per meter squared, and it looks at things like heating, lighting, and hot water. So it looks at that from that point of view. We then have CO2 emissions. So again, this is looking at the operational carbon, a target that's been there since the concept of SAP. And again, we need to hit that. We've got a fabric energy efficiency target. So without that, perhaps we could pass with just renewables and not have a fabric energy efficient building. But we have a standard set out for that. And we've got minimum standards for a fabric. So the U values that you can hit as a maximum. So again, we'll look at them a little bit in a minute. And then again, minimum requirements for fixed building services themselves. So just looking at those minimum standards that we have, we've got set out here, you can see all roof types. We've got a U value of 0.16. So again, looking at the measurement of heat loss through a given makeup. So again, they look at the conductivities when we look at U values. So if you have a typical masonry wall, you might have a brick outer skin that would have a resistance in the brick. Typically, you divide the conductivity down by the thickness, and that gives you the resistance. You then might have a cavity or a full fill, PIR, maybe insulation between. So again, you'd work out the resistance of that product. You then have typically an inner block, 100 mil, again, working out the resistance, maybe dot and dab, plasterboard and skin. Again, all of that works out the resistance of the product, which in turn gives you the U value. So walls are at 0.26, you've got floors at 0.18, party walls at 0.2, swimming pool basin at 0.25, window at 1.6, roof lights at 2.2. Doors at 1.6 and then air permeability of 8. So these are absolute backstops from a new build point of view. So you can't go any higher than these. And they're designed in there because SAP is a recipe. We'll go through the notional dwelling in a minute, but SAP is a recipe. So you can make small changes to the U values. So a prime example of that might be in a wall, in a dormer cheek, which is classed as a wall. You tend to want a nice slender wall thickness rather than having quite a large thickness. Aesthetically, it looks a bit strange. So again, in those small areas of triangular panels, you can take that U value up to 0.26, but you must make the adjustment elsewhere. So again, you can do that because there's such a small area. You can do that with minor adjustments and still hit the standards. But again, if you set out a building to try and hit all of these standards, but again, from a self-build point of view, I wouldn't expect you to do that. You wouldn't pass SAP, it just wouldn't happen. We then have what we call a notional dwelling. So again, you've got the table 1.1 summary of the notional dwelling set out in Part L, Volume 1. So again, in an ideal world, if you complied to everything that's on the notional dwelling, you would be deemed to achieve and comply with SAP. So you've got things like thermal bridging. So again, we talked about U values a little bit, I suppose, and again, previously with Rob. So U value is a repeating thermal bridge. So you've got repeating thermal bridges. Y values are the accumulation of non-repeating thermal bridges. So you've got things like a ground floor junction detail with an external wall, reveals, heads, sills around windows and doors, intermediate floors, junction details around roof junctions, maybe ridge beams, veluxes. There's 44 details in total that must be considered. And again, what they are is they're called psi values. So this is thermal bridging. Psi values are linear. So you measure them linearly. They get added up and they make a Y value. Y value is quite simply a penalty to a U value. It's something that you wouldn't see. As an energy assessor, it's something that we do in the background of SAP. So again, I'd expect most people to know what a U value is. I would expect most people probably not to know what a Y value is. And again, you can get those details from manufacturers like ourselves and other database sources. They have an air tightness of 5, so that's pretty standard. Rob would probably agree, fairly easy to achieve in pretty any construction. If you take that below 3 in SAP and don't force the ventilation, don't have a mechanical ventilation system, you would fail SAP. So it's just recognizing that with good air tightness comes ventilation. So again, that's useful. We're still on mains gas boilers for 2021 from a regulation point of view. We're not quite ready to switch over to things like heat pumps. And again, that's more of an industry thing, manufacturers and training and the skills that we have currently, getting that sorted. You've then got wastewater heat recovery systems. So again, these sit on the underside of a shower trap or a bath trap, take that waste transfer heat water that's coming out through the trap, which is significantly less than what leaves the shower head, but it's significantly warmer than what is going back into the system. And effectively what you're doing is you're using that energy in the heated water to reheat the water that goes back into the system. So it's like boiling a half-boiled kettle, in essence. It takes less energy to use. So that sits in there for the lifetime of the building, no moving parts, no maintenance. So again, it's a good renewable technology, albeit it doesn't actually need any work to it. Then you've got photovoltaic panels. So they suggest that 40% of the ground floor area divided by 6.5 would give you the amount of PV that's required. So again, this is just the notional dwelling. You don't have to do it like this. It can be done in any number of ways. It's like baking a cake. No one recipe is necessarily correct. And again, it's giving you choice. From an external wall point of view, they look at the U values at 0.18. Again, I've got some insulation specifications at the end, can be achieved in a number of ways, but I'll give you some of the PIR ones towards the end. The party wall at 0, which is fully filled and sealed if you were building terraced houses or multiples. You've got floors at 0.13, roofs at 0.11, doors at 1, and then windows at 1.2. So like I said, in an ideal world, from a new build point of view, if you achieve that, you would pass SAP. Again, I widely expect most of you to want to go over and beyond, because it's your own houses and you want to see the long-term savings. So looking at existing buildings, we've got, again, limiting factors. So these are the absolute backstops, again, the maximum U value that you can go up to. So you've got 0.15 from a roof point of view, you've got 0.18, which is the same as a notional dwelling for a new build on external walls. You've got floor at 0.18, swimming pool basin at 0.25, windows at 1.4, roof light at 2.2, and then doors at 1.4. Again, these are set out so you can't go above them. And again, it's looking to reduce that CO2 from an operational energy point of view. Which brings us on from an England point of view to the Future Home Standards. So again, this document is in consultation, well, it will be in consultation from 2023. We've got an indication of where they think it's going to be. So again, we're looking at 75 to 80% lower carbon emissions from an operational point of view as per the 2013. And they expect to do this through high levels of fabric standards and low carbon heating systems. So there is a consultation in 2023. They expect the documents to be released in 2024 and then implementation in 2025. And again, what we're looking at is gas, oil and LPG heating systems no longer being provided. So getting rid of that fossil fuels and very much looking towards heat pumps. They'll reduce the primary energy, CO2 and fabric energy efficiency targets, and then they'll review the minimum standards for the fabric and fixed building services. So we know it's going to happen. They've indicated a draft notional dwelling specification. So when you look at the floors, they're at 0.11, so they've reduced that slightly. It's about a 25 mil increment of PIR. And the external walls at 0.15, going from 0.18. Again, whether that's a partial fill or a full fill, that's around about a 25 mil increment. And obviously we've discussed, Rob's discussed, how we value houses and commercial buildings and industrial buildings. It's all done on square footage. So the more slender the wall, technically, the more floor area you have. So again, from a roof point of view, that remains constant at 0.11. The windows go from double glazing to triple glazing, which is good. They tend to be heavier, they tend to cost more. Acoustically, they tend to perform better. From a embodied carbon point of view, they tend to be sort of slightly worse. So there's, again, it's pros and cons to just about everything. So they have some good and some bad. Door U values and air permeability remains constant. Then we start talking about the heating appliance. So they start looking at low carbon heating systems, and they talk about heat pumps. That they very much mean, from this point of view, in this term, air source heat pump. And that's widely pushed towards the capital cost. Whilst they perform very, very well, the capital cost of an air source heat pump is less than a ground source or a water source, albeit the long-term gain, they're more efficient if you use a ground source or water source. But like most things, these tend to be led from a national point of view. And again, we then tend to look at capital cost, unfortunately, is the driver. The emitter type, so how's the heat emitted? Traditionally, we've used radiators, which work very well with high emitter type systems like gas boilers. Heat pumps won't generate that type of heat to make them work. So again, we're looking at things like underfloor heating that work very well with under 45 degrees, which work very well with heat pumps. That change has also been made in the 2021 regulations. They look at the notional dwelling to have a low temperature heating system or heating emitter. And the general reason for that is when we talk about retrofit, you know, installing an air source heat pump is an expensive thing to do. And I talk from a 3-bedroom house down here in Devon. My best mate happens to be a plumber and said he would put an air source heat pump in my house as a mate for £15,000. And I struggled to see how much of a mate he genuinely was. But again, when you look at that, a lot of the cost, obviously you've got the heat pump themselves, but a lot of the cost is down to changing all of the radiators and putting a different emitter type in, which is disruptive, which again adds to cost as well. So they're trying to recognize that if we're going to go over to these low carbon heating systems in the future, that they can start to make those changes, which make the impact less in the future for us. Ventilation systems have always been standard with natural ventilation systems, and I understand what Rob was saying about making the buildings more airtight and again forcing ventilation with mechanical. And at the moment they're suggesting no PV, but I think we'd all like, in an ideal world, again from a self-build world, having PV is a benefit. We don't talk about things like the electricity heating, sorting the lighting, sorry, we talk about it from a heating point of view. But I think we'd all appreciate if we had PV on our roofs right now, we would be paying less for electric, which would be absolutely fabulous. So just going over to Wales. So again, both documents, we've got England, Wales, Scotland and Northern Ireland. All 4 documents are different. So the Welsh document is being released on the 23rd of November this year. Again, they'll have a similar 1-year transitional period. It's going to be at 37% lower carbon emissions than their 2014 regulations that they have. They differ slightly when it comes to the SAP metrics. And again, from a platform point of view, they've got the primary energy target, which is coming in. They've got the CO2 emissions target, which is constant, like I said, with the 37% reduction. What they don't have is the fabric energy efficiency, and I'll cover that off in a slide in a minute. They do it quite well when it comes to looking at the fabric because of their minimum standards that they've set out. And then they've got the minimum requirement to the fixed building services, so looking at temperature heating and time and temperature controls with the systems themselves. So you can see here table 4.1 from Part L Volume 1 of Wales. You've got new dwellings and existing dwellings, and you can see down through the chart there that they're pretty much the same there. So you've got roofs at 0.13, walls at 0.18 in a dwelling, 0.21 in a flat. You can already see that, again, from a roof point of view, we're close to the notional dwelling that we have in England being proposed, which is 0.11. The walls are the same at 0.18 in a dwelling. The floor is slightly higher at 0.15, so we're 0.13 in England. Party wall at 0.2, swimming pool basin at 0.25, windows at 1.4, roof lights at 2.2, doors at 1.4, and air permeability of 8. So it's very, very similar to the notional dwelling as well, with the exception of a few little items there. But again, that's their absolute backstop. So again, you can't go higher than these areas to achieve the UVO. So again, you have a notional dwelling set out for Wales, similarly E1 summary, similar to England. So you've got thermal bridging, again, that remains constant there at 0.05 from a Y value point of view. So again, it is quite a good Y value. Again, if you get below 0.01, that's passive house territory and classed as no bridges effectively. And I think Rob mentioned there about looking at the building's mass and everything else. When it comes to things like passive house, if you make it complicated and start having bay windows and stuff, you're introducing thermal bridges, which again, make it a lot harder because you've got to omit them to make it a passive house. You've got the air tightness again, which remains the same at 5. You've still got the mains gas boiler. You've got the wastewater heat recovery system the same, and you've got photovoltaic panels again in the same sort of measure as we use in England. So just touching on some insulation specifications themselves. So we have a product called Cavity Therm, which is a full fill PIR. Comes with pre-mitered corners that you can see there. There's various other ancillaries that we have in and around this, electricity backers. We've got telescopic vents in block and beam floors, which we have backers for. We have riser panels, which are built at 225. We also have trays, as you can see there, that where a low-level roof strikes a high-level wall. So this product was designed in a project called AIM-C4, which was done back in 2010 with Barratt Homes, Crest Nicholson and Stuart Milne. Stuart Milne adopted a timber frame, Barratt's and Crest Nicholson adopted a masonry design, and this product was developed with them. So it was developed specifically looking at solutions for nearly zero energy buildings. We looked at ancillaries like the pre-mitered corners around the thermal bridging, and we modelled these details for psi values. And again, we've grown the range from there. So they were first or completed in 2012. And again, the buildings were monitored to make sure they were set out to achieve what they were going to achieve, because that's one of the things when it comes to SAP is what we design against what actually happens, what's been built and how it performs aren't checked. And again, when we come on to Passive House, it is. When we come on to the RIBA Climate Challenge in a minute, again, that has a 1-year transition period where you do check over a winter-summer cycle. So again, it's interesting to see how buildings perform, and actually when you get an EPC and they tell you how much your electricity costs, actually what actually happens when that bill comes through the door, you tend to find they're quite a lot different. But you can see there the U value.
Just to give you your 3 minutes left, thank you.
That's fine. So you can see there we can achieve the U values of 0.18, 0.15 and 0.13 as set out in England and Wales. From a partial fill again, you can see the same. We tend to T&G and engineer joint everything we can. It's better detailing on site and in practice. Same with the high floor, that's a G&G product. You can see the 0.13 and 0.11 easily achieved. Pitched roofs can be not tricky, but we would always recommend either insulation over the top completely as a warm roof, or a hybrid with insulation over the top and in between, or insulation in between and to the underside. So just touching very quickly on our eco product. So again, we're the first manufacturer in Europe, at least Europe, to enhance our PIR using a bioenhancement. It's rapeseed oil. So we have that in our full fill, partial fill and general purpose boards. We have an improved thermal performance, which is consistent at 0.020. We've reduced the packaging by over 50%. And that packaging is also biodegradable. And then there's less waste because we'll do material takeoffs ourselves to assist with that. So again, it's a further push to trying to be more sustainable in the future. So just very quickly on the RIBA Climate Challenge. So 2 days after the government announced their decommissioning of the grid by 2050, the RIBA Climate Challenge was announced. They went on to version 2 in June of last year. But it's about looking at embodied carbon. So we look at operational carbon on everything. That's how we've always looked at things. But RIBA have gone on and said, look, we need to look at embodied carbon. What happens from the sourcing? What happens to the production? What happens to the on-site, the maintenance, the repair, the replacement, the disposal? So they've come up with a list of targets. You can see operational energy, embodied carbon, potable water. They've also got health and well-being, biodiversity and delivery. These figures, as you can see, for embodied carbon, less than 625 kilograms of CO2 emissions per square meter. They're not zero. The terminology zero carbon is it happens on site. Net zero is when you offset. And again, that offsetting process is done with RIBA and the UK Green Building Council and things like free peat bogs and various other things. So And again, you can just see here then it's the processes associated with sourcing materials, fabricating them into products and systems, transporting them to site and assembling them into a building. And then they include the emissions due to maintenance, repair and replacement, as well as the final demolition and disposal. So there's many ways to look at sustainability. The global warming potential, which is CO2 emissions and all greenhouse gases, is one step. And again, you can do that for an EPD, which are available through manufacturers like ourselves. There's things that we've discussed, VOCs, which is volatile organic compounds. Again, it's another way of looking at sustainability. So it all comes together. There's lots of things. Sustainability is something that we could talk about all day and we wouldn't sort of scratch the surface. But this is me, this is who I am. You've got our technical details there as well for U values and various other things, but I'm more than happy and willing to look at your projects and sort of help you out.
Great, Martin, thank you so much. And I know it's very difficult to get all of that information across in a 20-minute slot, so thank you so much for that. Martin, I'm just going to put one question to you, or it's a thought really, and it is an interesting one. So it's from Kirsty. You obviously touched on the Future Home Standard, which comes in 2025, I think. Are you aware, are the government having a similar scheme for the existing properties? You know, so there are, you know, as we touched on earlier, millions and millions of homes that are going to be nowhere near the Future Home Standard, and obviously that's with the new build homes. What are the government doing, as far as you're aware, to help us tackle these existing properties?
Well, again, there's a government scheme at the moment looking at retrofit. The Retrofit Academy are working with them to try and get people up to speed. So it's getting the skill set out there as well. So people like myself have to have the skill set to be able to demonstrate what we're going to do. The 25 million plus houses that you talked about and stuff earlier, not all of them need retrofitting. But again, it's going to be hugely complicated. There will be more grant schemes being made available. It has to happen for us to be able to do all of this. Obviously, looking at the existing private and housing association rental properties, they're going to have to come up to an EPC band C by 2025. That's going to happen. So again, they're forcing that through with legislation. But again, from a private point of view, I'm not entirely sure how they're going to do it just yet, other than they'll have to grant money, because people like myself and yourself living in our homes can't afford to do it. And I don't see how they're going to make us do it. So
yeah, it could be a huge outlay, couldn't it? No, brilliant.
Yeah.
Martin, thank you so much for that. So you're happy to join us for the Q&A a bit later on as well?
Yes, no, I'll be here drinking my lemonade.
Great stuff, lovely. We shall see you about 20 past 8, and thank you. Right, and we are going to plough on. So again, for those of you that have just joined us, we have 430 people online. So thank you so much for spending your Tuesday evening with us. Hope you're finding this helpful so far. I'm going to ask Jonathan Parsons from Marmox to introduce himself now. So Jonathan, if you can turn your camera on. Good evening,
Hello.
Jonathan. How are you? You well?
I'm very well, thank you.
Great.
Yes.
And whereabouts in the country are you, Jonathan?
Down at the head office in Chatham, Kent.
Great, excellent. Okay, good. So we've had, we've got Cotswolds, Devon, and now Kent. So we are getting across the country, which is good. So, Jonathan, as I pointed out, time is sort of fairly limited. So if I could ask you to share your screen, please, and bring up your presentation. And just while Jonathan's doing that, just a reminder, we are recording this session, so we will send you out a copy of this recording. So don't panic if there's an awful lot of information to take on board. We'll get a chance to rewatch it. Right, Jonathan, your presentation is there. I can see that fine. So if you'd like to introduce yourself properly and go ahead, I'll be here in the background.
Surely. So my name's Jonathan Parsons. I'm presenting to you on behalf of Marmox UK Limited. I'd like to thank Harvey and NSBRC for inviting me to present in this workshop. So today I'm going to give you a quick overview of Marmox, the products that we have in terms of insulating boards, and of course a product called Thermoblock that prevents heat loss between the wall floor junction. So Marmox is Marmox. So we're part of a group called CMB, consisting of 16 companies. CMB is based in Cairo, Egypt, and we've got a group turnover approximately 480 million. CMB stands for Chemicals for Modern Buildings, and we manufacture manufacture and innovate pioneering solutions for construction industry. Marmox UK itself is a family business within the group. Our offices are based in Kent, and we manage the sales, distribution, warehousing, so on and so forth from here. So moving on to the first product, I'd like to present you to the multi-board. This is an XPS Core, and I have to explain, we're a one-trick pony, so we only have one product, which is the multi-board in terms of an insulation board. And basically what this is an XPS Core with a cementitious face either side, and embedded into that cement face you have a polymer mesh. And as you can see, the surface on the cement is what we like to call honeycombs, which gives you an absolute, it gives you a great key for applying renders, plasters, and you don't even have to prime it. It's ready to rock and roll, unlike a lot of insulations. So Marmox multi-boards are highly insulating and 100% waterproof. They can be used internally and externally. You can render on them, plaster on them, tile on them. You can use them for floors, walls and ceilings. And as I mentioned, they're 100% stable, so they don't expand and contract. Whilst being extremely light and easy, they're really great to transport and incredibly strong, holding up to 100 kilograms per square meter of hanging weight. The multi-boards come in a range of different thicknesses with the corresponding R values, and obviously various different sizes. So we've been lucky enough to be involved in some really good projects. So we've been used in the Shard and Dundee Leisure, Paul and Facebook HQ, as well as some prestigious self builds around the UK. A significant market for our foam core board is within domestic bathrooms, where they provide waterproofing and thermal insulation. Another market for us is providing insulation for the underfloor heating system. Typical heat up time for underfloor heating systems without using Marmox boards is roughly about 3 hours for that tile to become optimum temperature. Using our Marmox boards or multi-boards, you can obtain that temperature within 15 to 20 minutes, saving you a hell of a lot of money. So as I mentioned, the boards are waterproof, and they're commonly used in commercial applications in terms of swimming pools and substrates for tiling. They are certified for external use, and they can deal with extremely demanding environments. So a lot of problems that we have in a new build is obviously damage from tiles, tile damage. Tiles become damaged for many reasons. One of the key factors is the thermal expansion and contraction and deflection of movement in the floor. Since the tiles can be relied upon to create a waterproof barrier, ingress water can get in between the tiles because the tiles don't create a waterproof barrier. So existing damage with substrates can manifest as cracks, tenting and debonding from the tile covering. So in recent times, we've constructed out of timbers, gypsum, plasterboard, cement boards, and because we're currently looking at increasing our insulating performance, multi-boards are now becoming an everyday product because they incorporate a stable surface. Modern building materials have their own problems, which is why the BS 5385 was created back in '89. So the current version of the BS 385, the types of timber that you can obviously use aren't relevant now, quite simply. Sorry, I do apologise. So whether a certain type of wood can be tiled on isn't the problem anymore, because the standard simply says you just cannot tile on it anymore. So how strong are multi-boards when used in conjunction with floors? To answer that in a very scientific way, that's fully 10 elephants of compressive strength, or 40 tons. So timber is not a suitable substrate. Very, very low U values, whereas if you're always using Marmox on your floors on top of your concrete substrate, you're always getting that those thermal values. So we're now looking at decoupling. Certain floors can't be tiled directly on top of because of lateral movement. A decoupling layer such as a foam core board will allow such floors to be tiled safely. Lateral movement is further exaggerated when joining to opposing materials like concrete or wooden floors. So foam core building consists of extruded polystyrene from polystyrene foam cores, usually with reinforced cementitious layers bonded between the two surfaces. Although self-extinguishing, XPS is classed as combustible, so therefore you will find restrictions as to where you can use it. First of all, we should mention that fire safety and the prevention of fire should be the priority of all manufacturers and building materials. Building regulations prohibit the use of any combustible cladding such as wood or insulation materials on the outside of buildings above 11 metres in Scotland and currently 18 metres in England and Wales. Although it is expected certainly for residential buildings in England and Wales will follow Scotland's lead and lower that to 11 metres in due course. Another part of building regulations appropriate for tiling substrates to consider is the resistance to moisture. England and Wales, English and Welsh building regulations require that measurements are taken to ensure moisture ingress into properties is addressed by careful design and the use of appropriate building materials. Foam core building boards, being waterproof, were developed for this very purpose and can reduce these 4 types of moisture ingress listed. This is an example of how waterproof foam core boards can be used on walls, floors and ceilings, and actually in the swimming pool. These type of boards provide valuable thermal insulation, assisting in energy conservation and cost control. So some foam core tile backer boards can be used for external applications. Using a backer board externally can provide thermal insulation, waterproofing and enhanced adhesion, but advice should always be sought. In accordance with the England and Wales 2018 Part B fire regulations and Scotland Section 2 of the Building Standards 2020, products with a Class E rated core such as polystyrene should only be used as external cladding above specific heights. Further additional fire safety, we recommend that even use the lower levels should be closed fixed to a cementitious substrate such as a concrete wall directly to it. There should be no voids where airflow can assist the spread of fire. It should be noted that in accordance with the BS 3585, large format tiles and ceramic tiles with a surface area of 0.1 meters squared should be mechanically fixed. As we've discussed earlier in the BS 5385 recommendation, that substrate should be tiled but not dimensionally affected by water absorption. Unlike foam core boards, cement boards do absorb water and don't allow and will allow the water to pass through them. However, they aren't dimensionally affected. Therefore, although cement boards don't inhibit the passage of water through, do not inhibit the passage of water through them, both cement-based boards, foam core tile backer boards constitute an ideal and durable tiling substrate. So just quickly looking at the type of hanging weights that you can apply to certain substrates. This is very interesting. For instance, BS 5385 recommends that no more than 20 kilograms per square meter is hung from a skim gypsum plasterboard, 32 square meters from a gypsum plasterboard without plaster. However, if it is plastered, just remember that the hanging weight of a plasterboard goes down to 20 kilograms. Just to give you some idea, 12 mil thick porcelain tile and adhesive can weigh quite often more than 32 kilograms per square meter. According to the TTA guidelines from the foam core building materials have increased hanging weights of 60 kilograms per square meter. These weight limits include tile adhesive and grout. At this point, I'm happy to confirm that when we actually did our testing, we achieved 120 kilograms of hanging weight, so more than appropriate to use with large tiles. Very often, tile bathrooms are the coldest room in the house. So this is because of the high thermal conductivity of ceramic tiles. They're extremely cold. The room can feel like the North Pole at times. So condensation happens when water vapor in the air meets a cold surface, and the dew point of that's the dew points or higher than the temperature in the air. Condensation is the hazard, since dampness and can damage construction can occur. Furthermore, mold growth can subsequently happen, which is a hazard to health if left untreated. So a brief diversion from tiling, an alternative application for foam core tile boards is the internal insulation board. Some boards can be plastered as an alternative to plasterboard, which can be very useful. If certified for external use, and ours is, they can also be used as an external insulation board under renders, subject to fire regulations, which I've previously discussed. So as previously talked about, there's a limitation on where combustible EWI boards can be used. Insulation boards on PIR, PUI, XPS or EPS or phenolic are all classed as combustible, and they can only be used in strict accordance with national building codes. Fire safety for combustible materials are frequently being revised, but appropriate building regulations, building standards can be obtained from official government websites. An advantage of using XPS core boards for this application is that they can be manufactured in thinner sheets. The insulation properties of the thinner sheets is not as effective for insulation, but it can be an absolute godsend when it comes to space problems. So again, because foam core boards provide thermal insulation, suitable boards are excellent for use under tile heating. Insulation boards should always be sought from the manufacturer to ensure that they're suitable for this application. Electrical underfloor heating cables can be installed directly on the boards. And just quickly looking at creating a waterproof sill, then we've got various different accessories that can go over the joints to create a complete waterproof joint. Also the adhesives that we use in between the butts of the boards to create the primary waterproofing between the joints. So, and finally, the last section in this particular product, we're looking at, obviously, because the Marmox multi-boards are insulated, you can use them anywhere. We use them primarily in wet environments, internally and externally. But the great thing about our product is that we can use it as a construction product for quite a lot of different applications, one of which is foam core shower formers. They're really easy to install. They already come assigned with a preformed gradient, and they comply with BS 5385. As you can see here, we've sat them on the floor, we've tiled them, and you're not just installing a wet room tray here, you've actually got the insulating qualities to go with it. So specifically a foam cord shower former, all the joints are taped, so you can use our boards for walls, floors and ceilings, as I mentioned. And the shower trays do come in various different sizes. Just very quickly, you can sit them onto the existing floor, or in between you can bridge between the joists and sit them close to the top of the joists. So other products that we make are waterproof insulated niches. These are very helpful, becoming very, very popular at the moment. And one of the things about using installing niches is, especially when you're making them from any other product, as opposed to using multi-board foam cord material, is that you're really losing the insulating quality in the wall. So using these particular niches are actually fantastic. Another product that we use, which is vitally important, are the curve boards. These are again foam core XPS cord boards, and we've just very simply slit them down the lateral. We've cut them down the lengths or the widths to allow the boards to be bent around a radius. Also, another use for this type of insulation is on balconies, tiling terraces. We've got this board here, which we call the slope board, which already automatically comes with a fall. So you can use this in showers, but predominantly we use this for balconies for easy runoff, for rain runoff. So very quickly, and this is just another picture of our slope boards. How am I doing for time? 22 minutes. Okay, so very quickly, we're just going to quickly look at the Thermoblock. I forgot the name of my own product then. So the Thermoblock is an ingenious product that we created. It's basically very similar to the multi-board, except what we've actually done is we've filled it with concrete columns. Now, thermal bridging is an extremely problematic situation. So there are different types of thermal bridges. Non-repeating thermal bridges are part of the Y calculations in SAPS, and repeating as part of the U calculation, but specifically we want to highlight the water floor junction, which is a non-repeating thermal bridge, but also a geometric and a material bridge. You can see the images here, just showing the picture in the bottom right hand corner, how much heat loss is coming from the base of the wall. So this is how you're
Jonathan, I'm going to give you 60 seconds to wrap up. Sorry, thank you.
No problem. So this is how your total, I'll tell you what I'm going to do. I'm going to quickly just skim straight forward to, so this is a typical thermal bridge where you're losing up to 2/3 of heat loss through the thermal bridge here. And this is the essence of what's happening when you're not dealing with a thermal bridge. You're getting condensation, and this is an extremely important aspect to look at. You can see the thermal imagery shows exactly where the mold is being produced. And this is really being caused by a dew point by not dealing with the thermal bridge. Just quickly, this is a building built under the Part L, so it has very good U values, but you can see the weaknesses that are being addressed by not actually dealing with the thermal bridge. That's why the thermoblock is so essential in all modern construction types. Yeah, let me just quickly show you, apart from
then
this.
I'm sorry, I'm going to wrap you up.
No, fine, that's fine. Sorry.
We've gone well over time. So a bit frustrating because we wanted to have a look at that, but we've gone well over the time, and I do want to keep to time in fairness to everyone else. So Jonathan, we will see you again for the Q&A. Thank you.
Thank you.
Hi Jasper, I can see that you've already joined us. So apologies guys, but in fairness to the presenters, I'm trying to keep on track, and I think that was frustrating because it just got interesting with 1 minute to go. So Jasper, welcome. How are you?
I'm good, Harvey. Thank you for inviting me.
No, pleasure. And whereabouts in the country are you, Jasper?
I'm near Welshpool, where our office is in Mid Wales.
Great. And are you? I think it looks like you're in your office at the moment, right?
That's the trickery of Zoom.
I was going to say because it's daylight outside. So great. I see what you've done there. Fantastic. So Jasper, you were mentioned earlier. Actually, you were mentioned in Rob's introduction as your product being one of the eco insulation options that are available. So looking forward to hearing a bit more about you and what you offer. So if you can please start your presentation, that'd be great. Thank you.
Okay, so welcome everybody, and thank you for inviting me, Harvey, and very interesting to listen to the other speakers. I'm going to start explaining to you about our insulation, cellulose fibre insulation, warm cell insulation, and how that goes into off-site timber frame manufacturing systems. A little bit about our business first. We are distributors of warm cell insulation. We've got trained installers throughout the UK, and we ourselves use it in our off-site timber frame manufacturing on the construction division. PY Systems supply other building products for the sustainable building industry, and Xblock the machinery for delivering the insulation. So the key thing about designing a building is ensuring that you've got your insulation levels right. What we see is probably one of the most important factors for a building. And so you will design it, architects yourselves design what performance you want to achieve, and there is, I'm afraid to say, some appalling performance gaps throughout the industry. And I'm just going to show you here how, so this is a wall construction. If you've got gaps on the inside of your insulation layer, gaps on the outside of your insulation layer, so in your wall panel, for instance, you will get movement of air. That movement of air will cause cooling. If within a closed panel, you have gaps within your insulation, you'll get convection looping. That convection looping will also cause cooling. So the ideal situation is where you have a fully filled, dense packed insulation where with airtight and windtight, so you get no transference of heat loss through this building. These are photographs of, I'm afraid to say, real life situations where cut to fit insulations clearly haven't fit. And the thermo imaging taken under airtightness testing shows the cold bridging points and gaps in the insulation layers. So we advocate blown fibre insulation, and cellulose fibre warm cell insulation is what we use. This can be blown into any application within a timber frame, pretty much most aspects of a building apart from brick and block cavity wall situations, which you have to be extremely careful about insulating those. We also use it for party walls and floors for acoustic insulation, so that really helps with the sound deadening. Manufacturing process of cellulose fibre, it's recycled newspapers, which is cut, milled to optimum size to produce the insulation, and then it's heated to high levels where boron salts and magnesium sulfate salts are added to prevent insect attack, any kind of moisture damage with mold growth, so it prevents that from happening and gives very good fire resistance as well. So here are some of the key figures for the insulation properties. Very similar lambda value, that's where you calculate your U value. The lambda value is 0.038, and that falls in line with pretty much most other fibrous insulations. And the key reason that cellulose fiber dense pack insulation works well is it's injected under high pressure, and the density within a wall structure is one of the highest that you get with any insulation, so up to 65 kilos per cubic meter. This really helps keep your building cool in the summer and gives you much better stability of temperatures and warmth throughout the winter. Advantages of using natural fiber insulation products is you are locking carbon into your building, and the embodied carbon is equated as a global warming potential of what it will produce, and so very little carbon emissions are produced from using natural insulation products such as cellulose fiber. So, little picture showing you the reaction to fire. So what happens in this situation is that's a 1,000-degree blowtorch, oxyacetylene blowtorch, actually melting a penny on my hand with a layer of the warm cell insulation, and by water crystallization of the salts, moisture is driven into the paper, which causes that charring, and that charring helps prevent further burning. As you can see, it clearly resists that heat from transferring to. We've tested this out on some build systems, so on twin frame systems and I-beam frame systems, which is what we work within, and we got up to 89 minutes on our fire test through a wall structure. So installation methods, it's injected into walls and sloping ceilings or open blown into lofts using various tools and equipment with the X-Floc machines. Very quickly wrapping through here, you see the open blown technique for lofts, injecting to sloping ceilings, injection with a nozzle through into wall panels. We used to spray it with a bit of water, but that's not used very often these days. And then this particular method is into flat panels in a workshop, which is how we fill in our workshop, and then the full production facilities in the bottom right. So U value is achievable, and obviously depends on all the other different materials that you use within your wall structure, but we would calculate these out and aiming for optimums of 0.13 down to 0.1, depending on what U value requirements were required, and depending on what targets you're wanting to achieve. We frequently work, and majority of our actual builds are to Passive House standards, so getting to very high levels. All of these aspects of construction have to be tested, and a quality control procedure, particularly for the insulation, to ensure that there is no settlement, no movement. We do core testing, all our installers are trained, and core samples are taken and tested to ensure that the density is correct, among with the other aspects of airtightness testing, psi values, etc. Let's recapping on the properties. One of the key things that we found because we do our own airtightness testing, and we've done airtightness tests prior to injection of insulation into timber frame panels and then post that work, and we found we get a consistent 30% improvement in airtightness, one of the many benefits of using blown fiber insulation. So moving on to offsite construction, we have an I-beam offsite panel system for high performance housing, and these are the clear advantages you get from it. One of the particular points, which is what we're focusing on tonight, is ensuring that you get the quality you need with the insulation levels. Simple diagram here showing you how the panel structure is made. So you have a breathable, vapor permeable board on the external side, and on the inside of the building, an airtight vapor type board, and we pretty much always fit a service batten on the inside so that all services run within this service zone. So you're not cutting holes through your airtight layer, not running risk of any moisture penetration within that structure. So the design process for your builds is really important with offsite manufacturing. A lot of the work has to happen offsite because as soon as we arrive on site with a panel structure, within 2 weeks, you've got a house built. So you have to make all these decisions beforehand. And we typically would allow something like 12 weeks for that design process to happen. Engineering, panel drawings, etc. Mentioned before, fabric first. Fabric first is the mantra, definitely the mantra for construction and housing. And to enable that best performance for all your building, early engagement. And we would really advocate that you look and consider all these aspects at an early stage in your building construction. If you're wanting to work to Passive House standard, then PHPP, the Passive House planning package, is essential to ensure that you are going to reach those targets. But we use it on all our builds because it enables you to get a really good picture of how your building's going to perform. So not just from energy consumption for heating, but for overheating, heat loss, air tightness testing, and all other aspects. It was mentioned earlier in some of the presentations about air tightness testing being 8 or 5. When working to the Passive House standard, you have to get to 0.6, and we frequently will be easily beaten that. And I think the best air tightness test we've achieved on one of our buildings was 0.08. The other strong reason for having early engagement in design in your building is to ensure that you are going to build to the budget that you've got. So there's no point in us designing and building a house or attempting to build a house for you if you haven't shared that budget. So if you want to build to £1 million, we can build to £1 million. If you want to build to 500,000, we can tailor that build to 500,000. There's nothing worse than finding out at the construction stage post tenders that you haven't got the money to do the build. So very important to ensure that that value engineering process happens at the early stages of design. These are just show you the process from when we receive drawings. We do 3D modeling, engineer the project, and the manufacturing drawings. Panels are made on the benches and closed on one side, turned over, closed on the other side, and then the insulation is injected down the end of the panels using this lance method, which gives you that dense pack within the panel and ensures that every aspect of every corner is filled to the densities required. These are showing examples of completed panels with your airtight layer internally, and this is on this side with the service battens, and then your wind tight and weather protection layer on the external side. And when building, we would bring in windows in pallets to fit on site, even packs of plasterboard ready for contractors to carry on to finish the building. So there's an overview of the panel makeup. So you've got the air tightness, vapor control layer on the inside, tape joints, taped to windows. You can see your services running in through there. And then trying to avoid cold bridging and minimize that at floor junctions, fully filling floor panels for acoustic reasons and partition walls as well. Just going to run through a few slides of projects where warm cells being used for insulation. And so this is an excellent project that was built in Norwich and designed by Mick Aldrich's, built by Norwich Council, and actually achieved Sterling Prize Award. This is a building that we built, turnkey passive house. So this was a certified passive house. And a lot of people sort of consider that a passive house building can look different, but there's no reason why it can't be look very similar to another house. There's nothing particularly strange about it. It is in fact what we see as the best way to produce that comfortable home, that house which is incredibly comfortable to live in. This is another project in Surrey. This was an interesting one where the floor cassette had to be built because there was a root protection zone, so it was built on mini piles, and the whole frame was wrapped around and built within 3.5 days. The roof was on. And a very small little project local to us in Wales. I hope that caught back up with your time, Harvey.
You did, Jasper. Thank you very much. That's excellent. Thank you so much for that overview. Yeah, really helpful. Jasper, there was just one specific question that came through, which I will ask you, as you did help me catch up on time. Thank you. So where was it? Yeah, Don was just asking, I think you did mention this in terms of the Lance method of filling your panels, but it's just said, does warm cells settle over time and therefore potentially leaving an air gap at the top of the panels?
No, that's the whole purpose of injection to the high pressures. So there's a range of densities that are required to prevent any settlement. So from a 90 mil wall, we'd be putting in 45 kilos a cubic meter, up to a 300 mil wall, which would be 65 kilos a cubic meter. And so that prevents any future movement.
Excellent, brilliant, good. Jasper, thank you. So we're going to move on to the Q&A session now. So I'm just going to stop sharing your screen, Jasper. Before we do that, Katie in our marketing team has asked me to plug a couple of things that are happening at the centre. So it's my turn to show my slides just for 1 minute. So there we go. So yeah, it would be churlish of me not to mention some of the things that are going on at the centre that I think will be highly relevant to everyone watching this evening. So we have crammed in as much information as we can in this 2-hour evening, and thanks to our presenters for helping us with that. If you want to drill into these subjects in a bit more detail, we have a couple of events happening live at the NSBRC next month in November. So on Saturday, the 12th of November, we have a workshop looking at sustainable homes, and we will actually have 2 theatres running at the same time, one for new builders and one for people with existing properties. And actually, we were having a discussion internally as to which was going to have the slightly bigger theatre, and based on the feedback and the poll earlier this evening, I think we will give the retrofit theatre the biggest theatre, because it was about 2/3 were doing existing properties. And then at the end of November, we have a 2-day passive house workshop, which I know Jasper will be presenting at and going through his system in a lot more detail. And that is a fantastic event if you are considering that method of design. We have some more online events coming up. So at the end of November, we are focusing on barn conversions. And then in December, we're finishing the year by doing some live interviews with a couple of case studies. So people that have just finished their projects, having used the centre in various ways. So, and they want to share their kind of how they found life on site, the things to avoid, the mistakes they wish they hadn't made. So I think that's going to be a really useful session in December. And finally, we have a range of courses that we run at the centre all the time. Now, one that might be particularly relevant to people joining us this evening is our guide to energy efficient homes. We either run that in person at the centre, but actually the next course that we're running is a virtual session over 2 evenings in November. You can see the dates there, the 8th and 15th of November. It's 85 quid. It is a fantastic detailed course with a huge amount of information, lower numbers, so you will get your questions answered live as Dave Hilton, who presents that course, undertakes the course. And if you're interested in that, if you use that code NSBRC10 when booking, and you can find all the info on our website, you get 10% off. So really good value. It really is an excellent course, so that's just something to be aware of. I'm not going to play that trailer, but trust me, it's a good course. So, right, okay, so now it's the Q&A session. So I'm going to ask all the presenters to turn back on their cameras and their microphones. And I can see we've got 64 questions via the Q&A button. So we've had an awful lot of questions. And as I mentioned earlier, maths tells me that in the next half an hour or so, we won't be able to get through to all of those questions, but I will do our best. And Tony, yes, the recording will be available, and I will have a look and see whether I can get you the chat bars as well, so you can see some of the questions and things that have been answered as we have been going on this evening. So, Rob, I'm going to come to you first of all, and we've had a number of questions this evening. James actually asked the very first question about how to insulate properties that have solid brick walls. So doing a little bit of research earlier, 31% of properties in this country don't have a cavity, they're solid walls. So what are the best methods to look to improve the efficiency and insulate solid wall properties?
No, some of this comes down to sort of the difficulty of wanting to actually do a deep retrofit to your property. That's where the problem lies. So if you are doing a deep retrofit to your property, then internal cladding is a good methodology, but the insulation material you use must be breathable. It's very, very important indeed that is the case. Now, the old adage of being the thicker the better has always been a case of being a good thing in terms of insulation. And the trouble, as we said beforehand, is if you're not careful, you can reduce the interior space of your property quite dramatically, which can obviously make an issue to your room sizes, especially since some properties do have quite small rooms. So looking into that into greater detail is looking at different types of methodologies. So one is using like an installative plaster. So the idea is you actually remove the existing plaster and then build it up on layers. But again, you have to increase quite a significant amount of space by doing that. There are sort of wood fiber material boards, which again you can utilize, which has a similar effect. But one of the best situations I've come across is a silica board-based product. There's a company called Aerogel, which do a very nice product, which has a high performance, which is quite thin. But unfortunately, it comes down to cost again. Usually the high performance and thin products tend to be a little bit more expensive. But generally speaking, that's normally a very good methodology of insulating sort of your external walls on solid masonry buildings.
Thank you, Rob. Does any of the panel got anything to add in terms of tackling existing solid wall properties?
Yeah, when it comes to breathability, Rob's exactly right. The thicker you make the breathable product to the actual wall, the more of the problem you can create as well. So just because it might be breathable, the thicker it is, you can actually cause a problem. So if you want to stick 150 ml of a breathable product on the inside face, it might actually cause as much of a problem as a non-breathable product. And again, there's things like woofy calculations that you can do, albeit they're not, I don't know how much experience, Rob, you've had with the woofy stuff, but they're not that accurate at the moment because of geographical locations. So again, we're having trouble, like you'd run a U-value calculation, we run a woofy one, which is about moisture movement through a wall. But again, the geographical information that we have means that you could be looking at a project in Swindon, but actually running it geographically on a project which is far further north, which makes it a little bit more inaccurate. So again, as time goes on, we'll get that information through and we'll be able to show certain things. Rob is quite right, things like PIR aren't a breathable product and shouldn't be used. There are a lot of work being done in the background by companies like ourselves on different products, which will have high performance, perhaps lower cost than the aerogels, which could be a solution in the future.
Thank you. Jasper, Sally's asking about, she's got 1960s bungalow and she's asking about the best way to insulate it without tampering with the existing cavity. So I'll come to Rob with that in a moment. But Jasper, do you get asked about filling existing cavities in older buildings? And are there any kind of must avoids in that scenario? Oh, just Jasper, if you could just unmute.
I certainly avoid them ourselves, mainly because there's a lot of unknowns on water penetration from external sides. So driving rain on a brick wall surprisingly can leak through that wall, and then your insulation gets wet, and then you've got migration of that dampness coming through to the inside. There's no known vapor control on the inside. So you have to be extremely careful with existing cavities. without knowing those factors. And certain parts of the country, particularly if you're by the coast, are also quite dangerous to do. So yes, I'd be very careful. It's not something we do. We actually do sell machines for extracting cavity wall insulation, which is indictment for the problems that you can get.
Thank you, Rob. Yeah, and have you got anything to add in terms of properties that do have a cavity?
I would concur with Jasper. I mean, when you're looking at these situations, I think you have to sort of take a sort of a measured view. So, if you've got a house on a hill, in a very sort of exposed area, that the risks of water penetration through the wall is incredibly high. If you're on a very tight-knit housing estate with houses very close together, which quite a few properties you see this quite frequently, then the risks are far greater risk, far reduced. But also just sort of a visual inspection of the external wall itself. If the pointing and the brickwork is in very good condition, then the chance of water migration again is far reduced. But generally speaking, it is a risk. It's as simple as that. Some insulation companies do say that their materials are less likely to for the water to wick across, but the whole rationale behind a cavity is to keep you dry. The idea is that the water will enter, hits the wall tie, and then drops to the floor. So that's the basic rationale behind that. So yes, I mean it can work. It can be advantageous, but there always are risks inherent with doing any works to an existing property. It's as simple as that. When we sort of buy these lovely old houses, we like them because they're quirky, they're interesting, and so on and so forth. But there's always elements which will be compromises as far as you take that forward, whether internally cladding insulation, externally, or within the cavity. So that's why when we design new and build new, it's a lot more straightforward.
Lovely, thank you very much, Martin. There was a question that came through on the chat. Just you mentioned the WFI score, and could you just touch on that and spell it so people can look that up if they need to, please?
Yeah, it's WUFI. I responded to it on the chat there quickly. Again, like I said, it's a hugely complicated way of analysing moisture movement for a wall, and it's not really, like I said, that 100% accurate at the moment, but that's going to be the way that we will look at things like that from a retrofit point of view.
Great, thank you very much. Okay, let's go to the next question. So there was a question around, from Jonathan, just regarding EPC scoring, which was mentioned. Do all the products that we've heard about tonight have positive EPC scores? And are all mortgage lenders happy to lend against properties that feature your products? So, Jonathan, have you got are you aware of EPC scores for your product, and any thoughts on that?
I'm sorry, I'm not. I can't answer that question. I don't know the answer to that, but I can certainly find out. I do apologise. I have to confess. My technical guys don't seem to be here at this time of evening at work. So, but I will find out and I'll get back to that.
I think Jonathan, the question might have been phrased wrong. I think yeah, that would be my view on life. Is the question's not necessarily meaning the right thing. We all got environmental product declarations would be a better question to ask, perhaps, which we all have.
Yes.
Which look at sustainability, look at the GWP. That's fine. The EPC rating really is not relating necessarily. It's holistic. It's looking at the entire building rather than just the product. And mortgage providers generally don't have an issue with installations or all the products that have been described. They're BBA approved. Again, building control will approve them. The warranty provider will approve them. Therefore, a mortgage provider wouldn't have an issue with the type of insulation. They wouldn't even question it. I don't think they used to question methods of construction back in the day. Jasper might remember timber frame used to be questioned. It was a nonsense. And again, quickly overcome, but I can't imagine any of our products that we've demonstrated today would have any issues with a mortgage provider.
No, that makes absolute sense, Martin. Thank you. So a question from Paul and Rob. This probably comes back to one of the very first slides that you showed earlier this evening. Paul's just asking where best to invest in insulation on a typical dwelling, and you know, we know from our energy bills it's quite difficult to actually ascertain what a typical dwelling is. I guess where is the heating you know, most likely to be leaving the building from, and therefore what makes the most sensible investment? Is it roof, walls, windows, flooring, loft, elsewhere?
So generally, normally the biggest bang for buck is a roof, principally because it's relatively easy to get to, and generally find that most roofs are pretty poor. How many times I've been told by clients, oh yes, my roof's very well insulated, and you go out there, there's sort of lucky if you see 100 millimeters sparsely spread over the area. So the roof is normally number one. It's very simple to get to. It's the installation is relatively cost effective, and it's a simple procedure to do either by yourself, or if you're not confident to do so, get somebody else to do. It's basically pretty much just a DIY job. But when you do it, you must be careful that you don't close off the eaves. The idea is that ventilation still needs to be brought up into the airspace to keep the roof ventilated. And I've seen people who lovely insulate it very, very well, but shove it really down tight and then cut the airflow and then get condensation in the roof space. So that's a really important thing to think of. The other biggest bang for buck, and it's very simple, is draft proofing. How many times I see people have got double glazing, which is getting a little bit past its sell-by date, and find that the seals are missing or the windows don't close properly. Simple little things like, you know, cat flaps. How many times I see half-broken cat flaps or letterboxes agape? You know, these are things which are not expensive to actually fix and sort yourself out. I mean, if it's really a case of, you know, you just need to last through the winter for your windows, just buy some sellotape, you know, and seal up those gaps. So quite often it's those little bits and pieces, they all add up together. There's no single silver bullet, I'm afraid. But I normally say that the simplest and most cost-effective thing is roof insulation, and then cut out on your drafts.
Thank you, Rob. Any of the panel got anything to add to that?
No, I think Rob summed it up. Heat rises, Rob, doesn't it, at the end of the day?
Yeah, I'd just add that something for Jonathan really is bathrooms. You get, you know, if you've got a cold bathroom, that's where you're going to get your worst problems, condensation issues. So if you're going to spend money insulating walls, etc., start with your bathroom and kitchen.
Absolutely.
And living room and bedroom, the hallway.
In that order.
Yes, yeah, pretty much. Yes, pretty much. Yes.
Okay, so I think this is quite a specific one, but we've touched on it, but I will just ask this. So either Martin or Rob, I think, would be a best place for this. So James is asking, can you add to existing cavity wall insulation? So he currently has 100 mil cavity with a 50 mil PIR solid rigid board installed. Is James able to retrospectively add more insulation into that cavity?
Do you want me to go, Rob, or do you want to have a go?
Well, I think we'll both have the same answer.
Yeah. So subject to exposure zones. Part C of the building regulations looks at the exposure zone. So typically, if you're in a very severe exposure zone with a brick or a porous outer facade, you cannot fulfill. So you wouldn't want to add additional insulation into that. Again, full-fill insulations, PIR mixed together, it wouldn't be something I would do personally. I would look at EWI or IWI if that's a route you want to go down. But you obviously mentioned 50 mil Celotex insulation, so your EU value of about 0.28, which comes below the threshold of a retained external wall element, which is 0.3. So again, you were within the limits of building regulations, certainly. So you could argue to a degree why do you want to touch it, but again, holistically, you should probably look at the entire thing rather than just insulation. But
Martin, you gave some lovely little sort of mechanisms that we know in our building trade.
Sorry,
yeah.
Too technical, maybe. So sum them up for me, Rob. Tell them the.
Well, basically, it's external wall insulation or internal wall insulation. So the idea is rather than trying to sort of add to the cavity, you're basically either going to add insulation to the wall externally or internally. Adding it externally does give an extra bonus. because if you add external insulation, you'll still, if you still have a sort of a block wall internally, you retain what we call thermal mass. Thermal mass is a nice thing to have because basically what it does, it works a little bit like a storage heater. So the idea is the walls do absorb heat from inside the house, which helps to sort of keep a sort of more stable temperature, if that makes sense. Has the added bonus, obviously, if we think back a couple of months ago, it doesn't seem that long ago, does it? We were sweltering in 30 to 40 degree heat. Thermal mass also helps to keep us cool as well. That's why, you know, the people who have these lovely old cottages with thick stone walls in the Cotswolds like me, reveled in it beautifully to walk into a lovely cool house during the sort of high temperatures because of very high thermal mass. So it is something worth thinking about. So external wall insulation does certainly help in that manner.
Thank you very, very much. Jonathan, a couple of questions from you, and they both refer to your product and underfloor heating. So I know one of your slides showed some electric underfloor heating laid on top of one of your boards. So Matthew's asking, their ground floors are concrete covered with quarry tiles, and they aim to install underfloor heating throughout on top of these. What's the best way to do that by adding insulation below? Would your product be suitable for that purpose?
Yes, absolutely. Obviously, you've got the great challenge of removing the existing floor tiles and going back to the substrate. There is obviously you can contact various different adhesive companies, and they do a product that you can apply directly over the existing tiles, and you can apply our boards directly on top. But you are building up your floor levels by doing it that way. I always like to go back to basics and remove everything and start fresh. In terms of the thickness of insulation, then we've got everything from 4mm up to 60mm. Although for optimum heat reflection, you're really looking at a minimum of a 10mm board to be used in conjunction with underfloor heating. The 10mm board, actually, just quite interestingly, was the one that was tested that gave us the 15 to 20 minutes heat exchange back up to the temperature set on the thermostat.
Jonathan, just on a similar theme, another Matthew just asking, can you use luxury vinyl tiles over Marmox and electric underfloor heating? So I appreciate you're not an underfloor heating manufacturer, but are you aware of suitable products, and would vinyl tiles work?
Yeah, sure. So LVTs are a fab product, and yeah, absolutely. What you would really be looking at doing is laying the insulation boards, underfloor heating, and then laying a screed over the top of it so that you can then apply your LVTs onto a flat level surface. And then, of course, you're going to get a kind of thermal mass storage from your underfloor heating, which will benefit you. Without the screed, then on-off ability is quite instant.
Okay, thank you very much, Jonathan. Right, here's another one now. So this is from Heather. So again, Heather's interested in retrofit insulation, and I think this evening has definitely identified a need for further sessions on this subject. Heather has a property that has a 6-foot void space under the ground floor boards. She doesn't want to particularly lift the boards up, preferring to insulate from below. Is there a product that the panel could recommend to help Heather with this situation? Rob, I'll come to you first of all. So she's got 6 feet void space under the ground floor boards, and she doesn't particularly want to lift the boards up. What options should she be looking at?
Well, if there's a 6-foot space underneath it, then obviously that's fantastic, because it means someone can get underneath and insulate it very nicely and very well. It's more of a case when there's a 6-inch gap, which we quite often find where it becomes a lot more harder. But where's a 6-foot gap, effectively, you can basically use any of these gentlemen's products to insulate it incredibly well, which is fantastic. Now, what's important with these kind of situations is that when you insulate underneath, I'm assuming you are suspended timber floor, is that the insulation effectively would then fit tight between the floor joists, but you must maintain a ventilation-free area through that. So what we do find with a lot of properties such like is that the area is not still ventilated. So one must be careful. I've seen many a property where they are ventilated floors, but unfortunately someone's built a lovely extension at the back of it or to the side of it, and the air vents have been closed off. So you don't have continual flow of airflow through that. So maintaining that's important. Now, when insulating underneath, two things you need to think about. One is the insulation, but also one is to cut out the drafts. And one thing we do quite often find with older properties is that there's always a floor joist just literally an inch or two off the wall, which is not then insulated because it's a bit of a swine to actually insulate that area. And that's where some products may be better than others to insulate that, because effectively if you don't, you get a lovely draft gap which blows cold air through that gap, usually at the joint where the floorboards meet the skirting board, because obviously everybody now has pulled up their underlaying carpets, have got lovely polished floorboards with big gaps in them. So that's why that becomes very, very important. So Jasper's insulation material might be actually very good in that respect to actually use it, because it fills in all the nooks and crannies in terms of that. What do you say, Jasper?
Yeah, I'd agree. I mean, if you've got a 6 foot floor place, you've got almost a room down there, certainly a good cellar. Yeah, you've got to get in there to do it. So you'll have to lift floorboards. If there's no other access, you have to lift floorboards, simple as.
Thank you, guys. Thanks very much. So this is an interesting one. So this is a question from Paul. So Paul, he's been working on a new building a few weeks ago, built to the latest standards. And the problem that he encountered was because there was so much insulation to meet the new regulations, they could not get a wireless signal into any of the rooms. Has anyone experienced this as an issue and found a product that keeps the heat in, but also allows in wireless signals? Yeah, has anyone come across that? Martin, is that something you've come across with any of your case studies?
Well, the wireless signal is inside, which doesn't relate to the external wall, roof, or floor insulation, but there is acoustic insulation, eh?
I mean, the only time I've come across that with foil back insulation, where effectively if they use foil back insulation throughout, then use it on the internal stud walls, that's when you can get problems. But I think
I can't understand for the life of me why somebody would use a thermal insulation for acoustics.
No, exactly. So it may be the case that sorry, the wrong material has been used, because if foil back plasterboard's been used on internal walls and ceilings, then that will cut out the Wi-Fi signal basically. We get more of a problem in old properties with thick stone walls, or some Victorian properties which have engineering bricks in the internal walls. That's when it becomes an issue. But generally speaking, it shouldn't really be a problem with sort of normal insulated walls, because effectively your insulation level is to the outside, not on the inside. So the only thing I can think of is incorrect products being used somewhere.
Yeah, Paul, if you're still with us and you want to put in the chat if you know which product it was, that'd be quite interesting to know. So no, I must admit I've not heard of that before. Okay, thanks guys. Right, let's go to the next one. We are actually managing to plow through these questions. Now, before I do ask the next one, panel, it is just coming up to 9 o'clock and the session is due to finish at 9. Are you all happy to extend this Q&A just for another 10 minutes to get through a few more questions? Thumbs up from everyone. Brilliant. Okay, so okay, Jasper's giving us 5. So we will just crack on then. So if you're happy to stay with us, we're going to carry on this Q&A session for the next sort of 5-10 minutes. If you do need to leave us, this session has been recorded. So as I said earlier, I will send out a copy of the recording in the next few days. And I will also send some further information about all of the companies that presented and a link to the events that I've mentioned earlier. Okay, let's try and pick a different theme. The main theme, I'm seeing this in the chat as well, and it's very interesting, is can we do more to tackle this issue with existing properties? So this is, I will capture all these questions, and it's clearly something that we absolutely will do. And I will make sure at that Eco Workshop on the 12th of November that we have companies and perhaps some of the panel here tonight who can spend more time looking at the problems that we all have with existing properties. Okay, so Sue's asking, is there a formula for costing insulation for a property? So she's trying to work out how much she needs to put to one side for upgrading a potential property. Is it different if the house is gutted or compared to it still having its existing room? So what kind of budget should Sue be putting aside to improve to a good standard, let's assume, an existing property? I'm sure there's a lot of variables. So Rob, I'm going to point this one at you initially.
It's a bit of an impossible question, to be perfectly honest. How long is a bit of string? The best thing I would say, the way of doing this is to come up with your target. So what your target installation value you're looking for. So you sort of and if you don't know what that is, I think it's best probably to get some advice as far as that, because you know, if you look at a number, that number doesn't sort of probably mean anything to you. So I suggest you probably do get some advice from a installation specialist or whatever to actually say, right, what does this actually mean in real terms? So the reason why this is important, because effectively going back to sort of some earlier sort of slides that I had, is your heating is dependent on several factors in terms of how much heat you require. So the insulation level will have an impact on that. So to work out what that actually means in real terms is you can have a survey done of your property, do a heat calculation, and the heat calculation will determine how much energy is required to keep your house at a certain temperature. Now that number, that kilowatt output, will be dependent on the insulation level of your property. So what you can effectively do, you can play with these numbers by improving the level of insulation to drop the heat number, the kilowatt output number. Now, what number you want or what number is sensible is, again, is a moot point. And the critical points become is when you start looking at renewable technologies. But effectively, if you want to reduce it by, you know, a factor of 10% or 20% or whatever, then when you've sort of come to something which is sensible, it also depends on the practicalities of what material you think you can actually use in your property. So it's not a very simple process to come up with. But once you've ascertained that, then you can say, right, now you can use product X or material X to a thickness of Y, and then you can get your square area of what you actually look into and get some costings done. And I'm sorry, there's no simple answer, because it is actually a particularly complicated system to actually look into and methodology to work out. So that's the kind of general process you have to think of. So first you have to work on your target, what your target you're looking at, and then once you've got your target, look in different materials which are suitable for your rooms, your house. I mean, say for example, you know, you're using different materials in different areas of the house, and that's why you've got to look at it in that way.
Okay. Yeah, no, that seems a fair question. Right. Here's one from Matthew. So this is interesting. So the boiler upgrade scheme, the government grant to change boilers to heat pumps, essentially, as part of the paperwork for that grant scheme, they're asking for proof of cavity wall insulation. So how can Matthew address this if you as a panel are kind of collectively recommending not installing cavity wall insulation due to risks of damp transfer? So I guess really for Matthew, I think the answer is going to be, Rob, it just depends on what he's got currently with the existing property. But what should Matthew be thinking about if he's considering? And actually, this is one of the questions that came to kind of highlight the need for this session. If people are looking to install a heat pump, particularly an air source heat pump, what do they need to be considering in terms of their insulation levels? Let's phrase it that way.
So the trouble with heat pumps is the sort of total output available of a heat pump. So with a gas boiler, you can just keep buying bigger ones. It's easy, okay? And we've been doing this for a very long time, producing houses which are very poor in terms of performance. We just put bigger gas boilers in. With the heat pump, it's dependent on your power supply. So with a standard power supply, you are limited to the size of heat pump that you can have, and that's the big crux. So depending on manufacturer and the different systems available, the actual output is actually quite low. So generally speaking, normally around about the 12 kilowatt mark for an air source heat pump, and around about 20 kilowatt for a ground source heat pump. And that's below the majority of standard houses within our country, unfortunately. So that's why the thermal upgrades are really, really important. So the way around it you have to do it is, again, as I said before, is you have to have the key calculations done of the property as it stands to understand what your kilowatt requirements are. And it's not just a case of looking at your boiler. We've done surveys. I mean, I did some apartments in London recently, and we found a 1-bedroom apartment with 4 radiators, and it had a 30 kilowatt gas boiler in it. So talking about sledgehammer and nut scenario, that's absolute to the extreme. It probably needed somewhere in the region, probably a sub 10 kilowatts. So that just shows you what you can find. So just by looking at your boiler, unfortunately, may give you an indication of the outputs, but not a distinct scenario of that case. So having the sort of the kilowatt outputs worked out for your property, that gives you your starting point. And you can say, actually, are we in the right ballpark for a heat pump, or are we not? So say for the argument, you're 15 to 20 kilowatts for your property. Potentially by doing some good upgrades of insulation, either external insulation or internal insulation, new windows, roof insulation, so on and so forth, you could quite easily get to within the scope that you require. But also don't forget the air tightness levels. So a lot of our sort of 3-4 bedroom houses can get down to the levels required, providing the work's put into it. So that's kind of the way around we've got to do it. So even before you think about boiler upgrade schemes, you have to do the sort of due diligence, the actual background work initially to make sure that it's actually viable to start with. Now, there is the option of obviously going big and getting a 3-phase power supply, and then you can go for whatever you want with heat pumps. But that's the kind of wrong way around, because if you do it that way around, just saying, okay, well, I give up, I'm not going to bother really improving the house, let's just get more power, which kind of is the wrong way around, because effectively you're talking multiple heat pumps, more money, 3-phase power supply, more cash, and then bigger bills. So it's, again, I'm sorry to bang our drum again and again, it's fabric first, and that's the way around, unfortunately, you need to look at it to start with.
Thanks, Rob. Martin, you mentioned that you got quite a painful quote for a heat pump from your mate, didn't you? So would you agree with Rob's summary there?
100%.
Okay, thank you. Right, I'm aware that we have 9:05. Jasper needs to disappear. So what I'm going to ask all the panel to do is just to wrap up this session by really just sort of giving their top takeaway, really. So we've still got almost 300 people online. So thank you so much for spending the last couple of hours with us. And whilst I give all the panel a minute just to think of their top takeaway to provide, just want to say, yeah, big thank you to Jasper, Rob, Jonathan and Martin for joining us and giving up their time this evening. It's much appreciated. And a big thank you to everyone at home for signing in and joining us for the last couple of hours. This has been a real learning curve for me, I think, in lots of ways, because tons of information that we've imparted over the last couple of hours, and I hope you found it interesting and helpful. But it has really highlighted the need for further sessions, and we will do our best as the NSBRC to cover that. And so, as I said, I will capture all the questions in the chat that have been typed out during the last couple of hours and take that back to the team, and we will just basically watch this space and we will come up with some new sessions. So hopefully you found it really helpful. So Jasper, I'm going to, before you disappear, just ask for your top takeaway for people who have joined us this evening.
Don't know about top takeaway. Clearly my business is, majority of our work is new build, and that is easy. And there's absolutely no reason why we shouldn't be building to Passive House standards with new build. It is very, very possible. Lots of people have been talking about external wall insulation, internal wall insulation, retrofitting, and that is clearly, Catherine, I agree with you, very, very important for the whole of our industry. It is complex, but it is possible. It just takes time, money, and correct detailing. So if you work on getting the correct detailing with the help from the likes of Rob and others, you can do it. It's just a bit more hard work.
Yeah, I know in the Passive House workshop that we're running at the end of November, there'll be at least 2 sessions specifically on retrofit. I think it's the Enefit standard, isn't it, Jasper, which is the Passive House Trust's standard for improving existing properties.
Yes, so it's less onerous than Passive House for new build. So Enefit, you still have to do measures to prevent cold bridging, etc., and fully insulate all the way around, triple glazed windows, and it is an expensive way to do it, but you do get that result of a very comfortable building to live in. Hopefully there will be funding available in the future. For it to happen, there's going to have to be. It really is going to have funding to help us sort out the retrofit situation we need to do. Just one other thing, sorry. What I find quite depressing is that we still are able to build houses to poorer standards if we stick to the minimum levels of building regulations. And
final point is phrasing.
Yeah, that's it.
Jasper, sorry, you just froze a little bit with your final point there. Could you just repeat that just for anyone that missed it, please?
I don't know how clever it was really, but just saying it's sad that we can build to minimum standards in new build, and we should be pushing these standards. Legislation should be there and help for the retrofit.
Great. Jasper, thank you so much for your time. I know you need to get going, so really appreciate you giving up your evening with us. Thank you, Jasper. That's fantastic. Jonathan, I'm going to come to you for your kind of final takeaway for the audience, please.
Sure. Well, retrofitting doesn't have to be a headache. I think it's very similar to saving money. You do it pound by pound, day by day. Retrofitting and upgrading your insulation should be done room by room. And my kind of last point is, remember, when you're increasing the insulation qualities of your walls, you're going to have more heat escaping from the floor to a wall junction. So remember and think about your thermal bridging.
Thank you very much, Jonathan. And Martin, come to you next, please.
Yeah, I think from my point of view, I just want to make it probably clear that there isn't one solution that's going to suit everything. There isn't one manufacturer that's going to suit it all. And I think, personally, I think retrofit is probably a bit more complicated than people do realise. And perhaps looking to a specialist and stuff like that, like a coordinator and stuff, a retrofit coordinator that's qualified and certified and insured at the same time is probably a good thing, because every building is different at the end of the day. So that would be my view.
Yeah, and I think that's come across kind of loud and clear, really, from the huge range of questions that we've had this evening. It's just a massive area, isn't it?
You can see me, Rob, and Jonathan, and we're not avoiding questions on retrofit. It's very hard to discuss a retrofit project with somebody on a text message. It's too complicated. I have a suitable level of insurance for my retrofit coordination, and it's you'd want to know and understand the building before you make a comment, because we're all professionals and we're liable for comments that we give. So again, sorry if everyone thinks we're being a bit vague, but that's the reason why.
Yeah, no, I think I agree with that, Martin. Thank you. That's a good point, well made. Thank you. And Rob, finally, so back to you. You gave us the kind of overview at the beginning of the session. So how would you kind of wrap up this surgery on insulation?
Oh, well, I'll echo Martin in respect that I know there's been a lot of chat coming up about retrofits, and retrofits are notoriously complicated. The age of the build, will have a different sort of method of construction. That all has an impact. I see some coming up about sort of listed buildings. They can be very complicated. One thing to not sort of bear in mind and not lose focus on is that we have a very old housing stock in this country, and some of us have bought, and I say some of us, and me included, have a lovely old stone cottage in the Cotswolds, which I adore, and it has limitations, and there has to be compromises, unfortunately, for us. So if we like to say let's go and build a brand new house up to passive standards, it'd be absolutely wonderful and very, very nice indeed in terms of performance. But then again, do we all want to live in identical boxes which have no character or style substance to them? And a lot of us live in older houses because they are characterful, because they are interesting, because they are quirky. And unfortunately, we cannot effectively keep that and keep the heritage, keep the history, keep the style, keep the substance by ripping all out and turning it into a new build. And that's something you have to think about. And you have to pick your level of compromise which you're happy to live with, if that makes sense. So if you've got curvy, weird, weird walls inside your house and you like that, then you can say, well, the best way of insulating that potentially would be to hack off existing plaster and use a installative render because it can follow the profiles. If you've got a grade 2 or listed building and there's certain elements of work you are not allowed to do, that's unfortunately that is a simple answer. That's the way you are stuck with those elements. And to think of, right, we have to use wooden windows, well, let's make sure they're draft proof. Okay, let's stop trying howling gale blowing through them. If we've got wooden doors which we're not allowed to change, there's simple little tips you can find. You can still get the old-fashioned Victorian style copper sealing strips which seal against the door frames, which allow movement and still can be really effective. I have them on my old wooden front door and they work a treat. So there are little things you can do, but you mustn't lose sight of the reason why you bought the house in the first place. You can't turn it into something it cannot be. So you have to pick your level of compromise that you wish to have. I mean, I have clients who have huge big open fireplaces and they said, I don't want to stick a wood burner in there, I want to leave it as an open fireplace. Fine, well then temporarily close it when you don't use it. It's as simple as that. So there's little bits and pieces that you can do, but unfortunately, we can't make everything be perfect. It's just a simple thing to do. So all I will say, my lasting message to leave you with is pick the level that you're happy with, pick the level that you're comfortable with and that you can afford, and keep it. But also, that's something that's important to you, then you must follow it through as well. So if you're going to say, I'm going to do this, then do it.
I think, yeah, compromise is a very good word. And Rob, based on your feedback, Steve saying that he's going to abandon getting internal installation, just buy a heavier pair of curtains. that might well be a wise move, Steve. So on that note, I
can vouch that I've got some pretty heavy curtains on my house.
Yeah, and as you said, sometimes the simple things do work, don't they? So it's been a great evening. Thank you so much, Rob. Thanks, Jonathan. Thanks, Martin, for your input and for giving up your evening. I know people that have really appreciated it. I can see that in the chat. And yeah, it's just, as I said earlier, this has really opened my eyes to the vast need there. As you said, Rob, 36% of homes, as we said at the beginning of the evening, were built before the Second World War, so it isn't going to be easy. And there's obviously a huge demand to find out more information about what we can do as we become ever more aware of our energy consumption and energy bills. But on that note, I will say thank you very much. Don't forget to visit us at the centre. The workshops that I mentioned in November are on our website, and like this evening, they're all completely free. And let's carry on the discussion there. Thanks very much, everyone. Enjoy the rest of your evening, and hopefully we'll see you at the centre soon. Good night, everyone. Thank you.
Good night. Thank you. Bye-bye.
Bye-bye.